Yesterday we talked about scale drawings for the first time, and today we're going to take that a step further and we're going to compute actual lengths from scale drawings. So this still relates to ratios and unit rates. There's 4 examples. If you don't have room on your paper, when I click to a new slide, you can be doing these notes on a separate sheet of paper and we'll just staple them together. So example number 1. Vincent proposes an idea to the student government to install a basketball hoop along with a court marked with all the shooting lanes and boundary lines at his school for students to use at recess. He presents the plan to install a half-court design as shown below. After checking with the school administration, he is told it will be approved if it fits on the empty lot that measures 25 feet by 75 feet on the school property. Will the lot be big enough for the planned basketball court? So let's look at the picture, and it says it's a scale drawing where 1 inch on the drawing corresponds to 15 feet of actual length. So what we're looking at here is the scale drawing. It has a length and a width. It's got a length of 2 inches for the scale drawing and a width of 1 2/3 inches. So what we're going to do is we're going to set up ratios, and then we'll be able to compute actual lengths. So let's make a table. On our top row we'll have scale drawing, and on our bottom row we will have the actual basketball court. So you guys still have your paper in front of you, and on your paper it says 1 inch on the scale drawing represents 15 feet on the actual basketball court. Well, if that's true, then 2 inches would represent how many feet on the actual basketball court? 30. So let's look at the drawing that we have for the basketball court, and we see that we have a length of 2 inches and a width of 1 2/3 inches. So the 2 inches was really easy to figure out. That's 30 feet. What we need to be able to figure out is 1 2/3 inches. How many feet will that be? So this was one important piece of information. We know that the length is 30 feet, or it could be the width. We just have to make sure it fits. So if we go back to our scale drawing, this 2 inches in real life is going to be 30 feet. Now that would fit if we're looking at the 75 feet. It wouldn't fit on 25 feet of width. So we'll check the other one and see if this thing will fit or not. Bottom line is we need to know how many feet 1 2/3 inches from this drawing will be in real life. Here's how we do that. We're going to pull information directly from the table, and we're going to set up what is called a proportion. So we know this. We have a unit rate right here. We know that 1 inch is 15 feet. So I'm going to write that down. 1 inch on the drawing represents 15 feet on the actual basketball court. We're going to set that equal to another ratio, and in this case it's going to be this one, where we do have an unknown. We do know that the drawing is 1 2/3 inches, but we don't know how many feet that is. So we'll represent that with a variable. We're trying to figure it out. So just like when you're working with equivalent fractions, if I said 2/3 is equal to 4 over blank, you would say, oh, well, you multiply 2 times 2 to get 4, so you multiply 3 times 2 to get 6. So those are equivalent fractions. We're doing the same thing here. So what do you multiply 1 by to get 1 2/3? Yeah, multiplied by 1 2/3. So if we do that in the numerator, we also have to do that in the denominator. So it sets up one of those problems that we've been working on in warm-ups quite a bit. And what we're really doing is 15 times 1 2/3. That's going to give you your answer. So 15, we'll write it as a fraction, times 1 2/3, we'll write that as an improper fraction, which is going to be 1 times 3 plus 2, 5 over 3. You can cross simplify. You don't have to. If you don't, then 15 times 5 is 75. 1 times 3 is 3. 75 over 3, or 75 divided by 3, is 25. Meaning that this unknown is 25. So the basketball court has one measurement of 30 feet and one measurement of 25 feet. Would it fit? The answer is yes, because we have a space for 25 feet by 75 feet. Basketball court is 25 feet by 30 feet, so yes, it's going to easily fit. Example number 2. The diagram shown represents a garden. The scale is 1 centimeter for every 20 meters. 1 centimeter on the drawing equals 20 meters in real life. Each square in the drawing measures 1 centimeter by 1 centimeter. Find the actual length and width of the garden based upon the given drawing. Now you got to be careful here, because we're going to find the length and width of just the garden, so we're not looking at this outside edge. We're just looking at these edges around the garden here. Okay, so its length and its width. So let's count up, first of all, how many centimeters the length is. Here's the length of our garden. 1, 2, 3, 4, 5, 6, 7, 8. I'm going to use a different piece of paper, a different slide. Remember, you can write this anywhere. We have a length of our garden in the scale drawing. Is 8 centimeters. And its width, let's count. 1, 2, 3, 4. So we have a length of 8 and a width of 4 centimeters in the scale drawing. Now we're going to use our scale to calculate the actual length and width. We know that 1 centimeter is equal to 20 meters. So in our table, I'm going to put that in. 1 centimeter on the scale drawing equals 20 meters in real life. So how am I getting from 1 to 20? Multiply by 20. We can do that by the same constant of proportionality in each spot in this table. 4 times 20 is going to give us 80 meters. 8 times 20 is going to give us 160 meters. So this one we don't have to do any work outside of the table. The actual garden has a length of 160 meters and a width of 80 meters. Okay, this is going to be the final example, and then you guys will try the exercise below this one. A graphic designer is creating an advertisement for a tablet. She needs to enlarge the picture given, so you're going to enlarge the picture. That's key. Remember from yesterday, this will be an enlargement, so it's going to get bigger. So that 0.25 inches on the scale drawing represents 1 inch on the actual advertisement. So what will the length and the width of the tablet be on the advertisement? So key is we're enlarging it, so it's going to be bigger than this scale drawing. Let's write down what we know. Here is the length, 1 1/4 inches on the scale drawing, so we're going to put that here. The width is here, 1 1/8 inches. And then we know the scale. The scale was given to us. It says 0.25. So you can write that as 0.25, or you can write it as its equivalent fraction form, which would be 1/4. So let's use 1/4 since we already have everything else in fraction form. And we know that 1/4 of an inch represents 1 full inch on the enlargement. So if we put 1/4 of an inch here, we know that that will represent 1 full inch on the enlarged advertisement. So then we ask ourselves, what do you do to 1/4 to get 1? To get 1 from 1/4, you multiply by 4. 4 over 1. That would give us 4 over 4, or 1. So what we did here is multiplied by 4. That's called K, our constant of proportionality. And once you have that constant of proportionality, you can use it everywhere in the table. So we're going to multiply 1 1/4 by 4, and we're going to multiply 1 1/8 by 4 to get these missing values that we're looking for. Because we want the length and the width of the actual advertisement. So we have 2 math problems to do now. 1 1/4 times 4 will give us this. And 1 1/8 times 4 will give us this. So we're going to go through and show our steps. First thing we want to do is convert to an improper fraction. We're going to get 5/4 times 4 over 1. Remember, you can look at your cross products. You can't simplify 5 and 1, but you can simplify 4 and 4. Both are divisible by 4. 4 divided by 4 is 1. 4 divided by 4 is 1. 5 times 1 across the top is going to give you 5. 1 times 1 across the bottom, 1. 5 over 1 is 5. So our length is 5 inches. Width, again, we're going to convert to improper fractions. We're going to get 9 over 8 times 4 over 1. Let's cross simplify if possible. It is possible here. 4 and 8 both have a common factor of 4, so divide both pieces by 4. This becomes 1. This becomes 2. We get 9 over 2. 9 over 2. 2 could go into 9 4 times, with 1 left over. Becomes 4 1/2. So we have a length of 5 inches and a width of 4 1/2 inches. And that's our answer.